Hello, my name is John Hill, and I'm a mission planner for the Themis camera aboard the Mars Odyssey spacecraft, and I'm currently based at the Mars Spaceflight Facility at Arizona State University. Today I'd like to introduce to you some of the instruments that you may be using in your research projects. The first instrument I'd like to introduce is my favorite, the one that I work on, which is the Themis camera, which stands for the Thermal Emission Imaging System. The Themis camera is on board the Mars Odyssey spacecraft, which has been in orbit around Mars since 2001. The camera is operated by Arizona State University, and it's a little unique because it can take pictures in both the visible spectrum, which is the area of light that humans can see, and the infrared spectrum, which shows you the temperature of the objects you're looking at. Now for the Themis Vis images, they have a resolution of 18 meters per pixel, which means that if you were to zoom in all the way into these images until you can see the individual little square pixels, those each represent an 18 meter by 18 meter square on the surface. Now, how can you use these Themis Vis images? Well, first of all, you can use them as basic images of the surface, just to look around, see what's there, see what you might want to study. You can also use it to measure small features, things like small craters, dust devil tracks, sand dune fields. And you can also use it for things like finding dust devil tracks. As you can see in this example image, the dust devil tracks show up as dark black, and the surrounding terrain shows up as light. And that's because the surrounding area in this image has a lot of dust on it. And when the dust devils go by, they clean that dust off, leaving behind the dark volcanic surface underneath. Now for the Themis IR camera, we actually have two different types of IR images. We take images during the day and during the night, and those two data sets look very different. So for the Themis day IR images, they have a resolution of 100 meters per pixel. So again, if you were to zoom in all the way on this image, all the little square pixels are 100 meters by 100 meters square. And for a sense of scale, a football field is about 100 meters in length. Now again, how can you use these images? Well, you can also use these as basic images of the surface, just to look around, see what's there. And even though they're lower resolution than the Themis Vis images, they cover a much larger area. So they can be used for reconnaissance on the surface. You can also use them for measuring large features, especially features that are too large to fit in a Vis image. You can also use these for finding things like wind streaks, and that's because when you have a wind streak, or a dust devil track for that matter, go over the surface, they'll usually either remove or deposit dust on the surface, which means that when the surface of Mars is heating up during the day or cooling off at night, those materials are going to have very different temperatures. And so those temperature differences show up very distinctly in IR images. Another use for Themis Day IR is for crater counting. If you want to get relative ages for two or more different areas on the surface, you can count the amount of craters in each. And since Themis IR images cover a much larger area, they give you a much larger area to work with, a lot more craters to include in your statistics. Now for Themis Night IR, it has the same resolution as the day IR images, 100 meters per pixel, but you can use it for much different things. And the images themselves, as you can see by this example, look very different than the day IR images. First off, you can also use these to find wind streaks, and in fact, I find the night IR to be more helpful in finding wind streaks because they pop out more, they're more distinct. As you can see here in this example image, areas that are rocky, that have lots of really hard, solid rocks, they retain their heat at night after the planet cools down, and so those areas will show up as bright white in the night IR images. But colder areas, like the very dark little craters in this image, are usually very sandy or very dusty, and so they lose their heat very quickly and are cold at night. And like I said before, when you have dust devil tracks or wind streaks, you're either removing material from the surface or depositing material from on the surface. And so those tracks have a very different properties than the surrounding terrain. And so especially in night IR, those will pop out at you and be very easy to find. You can also use these night images for finding and studying crater ejecta. As you can see again in this sample image, the ejecta from the two main craters here show up as bright white because when those impacts occurred, they dug out a lot of very hard, very solid bedrock, which holds on to its heat at night and stays really warm and shows up bright in these night IR images. And again, you can also use these night IR images to tell what type of surface you're looking at. Things that are really warm or bright white are going to be denser materials like rock. The lighter materials that might be gray might be sort of pebbly, maybe even sandy. And the areas that are really dark and black and cold, those are going to be things like dust or really fine sand, stuff that loses its heat very quickly at night. Now another instrument that you might be using as part of your research project is the CTX camera, and that stands for the Context Imager. Now the CTX camera is on board a different spacecraft, the Mars Reconnaissance Orbiter, which has been orbiting Mars since 2006. Now this camera is operated by the Malin Space Science Systems Company in San Diego, California. And unlike the Themis camera, the CTX is only a visible light camera. Now the resolution of these CTX images is a little bit higher than Themis Vis at 5.2 meters per pixel. Now how can you use these images for your project? Well, first off, they provide a much higher resolution image of the surface. So if you want to study small things, small craters, small sand dunes, they're much easier to measure with the higher resolution images. You can also use CTX to find small things like dust devil tracks, which tend to be much smaller, much finer than wind streaks. And so in this example image, you see the center of Gusev crater where the Spirit rover landed, and you can see details in the dust devil tracks. Whereas in Themis Vis, you might just see a dark area that represents a lot of dust devil tracks having gone through there. So in this case, you can use CTX to actually measure the length and width of the individual tracks. Also, CTX is a really good substitute for Themis Vis images when Vis images don't cover the area you want to study. And the inverse is true. If you don't have Themis Vis images, you might want to look and see if you have CTX coverage. The next camera I want to talk about is the HiRISE camera, which stands for the High Resolution Imaging Science Experiment. And as you can see from this picture, the HiRISE camera is an order of magnitude larger than the other cameras we've talked about. And because of that, it has a much higher resolution. Now, the HiRISE camera is also aboard the Mars Reconnaissance Orbiter, but it is instead operated by the University of Arizona. And like the CTX camera, it's only a visible light camera, but it has two different modes. It can either collect black and white images that cover a much larger area of the surface, or they can take very small, very localized color images. Now because the HiRISE camera and the telescope in front of it is so large, the resolution is much higher than those other cameras. It's at 30 centimeters per pixel. Now for a sense of scale, that is so small that when we look down at Mars at the rover landing sites, we can not only see the rovers themselves, as you can see in the sample image, we can also make out the tracks that they leave behind in the sand. So how can you use these types of images for your project? Well, first of all, you can use them as virtual landings to pretend that you're almost going all the way down to the surface yourself to see the very fine details of what's going on. You can also use it to better understand features that you're seeing in Themis or CTX images. For example, if you're seeing dust devil tracks or very small sand dunes, with HiRISE you can actually zoom in and see those sand dunes or dust devil tracks in very high detail. And so you might see that the dust devil tracks are not straight, they actually have very fine curves to them, which is not visible in the lower resolution images. Now the one thing to be aware of though with HiRISE is that there's very sparse coverage on the surface. because these images are such high resolution, they take up a lot of data volume. And so we're only able to send back 2 or 3 of these images per day. Whereas for CTX and Themis, we're able to send back dozens or maybe even hundreds of images per day. So you may not have high-rise coverage in the area that you're interested in studying. Now the last instrument I want to talk about is a little different than the previous cameras. It's called the TESS, which stands for Thermal Emission Spectrometer. And this was flown to Mars aboard a third spacecraft called the Mars Global Surveyor, which was in orbit of Mars from 1996 till 2006. Now while it was operating, TESS was also operated from Arizona State University. And this camera only worked in the infrared wavelengths, so the wavelengths of light that tell you how hot or cold the surface is. Now as I said, this is a much different type of instrument. The resolution of TESS was 4,000 meters per pixel, or 4 kilometers per pixel. So as you can see from this example image, the pixels are extremely large. They might only cover, one pixel might only cover a single crater. And in that case, you're only getting one value back, one color. And so it's very hard to see features on the surface. The advantage, though, is that since we're taking such low-resolution images, we're able to take them in a lot of different infrared colors. And as you can see from the bottom of the sample image, when we graph how bright or dark the surface is in each of those colors, TESS used about 150 different colors, we can actually get fingerprints for the type of rocks that we're seeing on the surface. Now, how can you use this data for your projects? Well, first off, these squiggly lines, these spectra that we get from measuring the darkness or brightness of the surface and all these different wavelengths are very difficult to use. And so what we've done for your projects is simplified it and made a group of mineral maps for Mars that show you where basalt occurs, where andesite occurs, where carbonates occur. And so you can just go in and look at these maps and see what the results from all these test spectra. Now the advantage of these maps is that, as I said, they can give you the composition of the surface, what the surface is actually made out of. They also have global coverage. So just about anywhere on the surface of Mars that you're studying, we have coverage with the test maps. And we will cover those maps and a lot of other maps in a separate presentation. So that's it for the instruments that you might be using on your project. I hope you found this presentation helpful, and I wish you good luck on your research projects. Thank you very much.